Hello. Today we will be learning how to convert repeating decimals to fractions. Make sure your table of contents is filled in. You should be converting repeating decimals to fractions around page 17 through 18. Remember, pause the video at any time you need to stop and just write things down. So we are still in Unit 1, the real number system. We are converting repeating decimals to fractions. Our essential question is, how do I convert repeating decimals to fractions? Okay. Well, we have to understand that a repeating decimal is represented by putting a line over the shortest group of repeating decimals. Okay, so if I have 0 and 4 repeating, I'm only going to put a line over the first 4 and not the others. Okay, if it's 0 and 6, 7, 6, 7, I'm only going to put a line over the first ones, and so forth. Okay, so that's the shortest. Remember, every repeating decimal can be expressed as a fraction, okay, because these are rational numbers. All right, let's start with changing decimals with one repeating digit. Okay, so we want to change 0 and 3 repeating to a fraction. So we're going to do this in steps. So step 1, we're going to say let n equal the number. Okay, that might sound a little confusing, so let's see what I mean by that. So n is going to equal 0 and 3 repeating. Okay, step 2. We are going to multiply both sides of the equation by 10. Okay, so what I mean by that is over here, because it has n equals 0 and 3 repeating, that's an equation. An equation has an equal sign. So if I want to multiply both sides by 10, that means I'm distributing a 10. So 10 times n gives me 10n. And then 10 times 3 repeating just means I'm simply moving that decimal place one place towards the right. So now instead of having 0 and 3 repeating, I have 3 and 3 repeating. All right, let's move on to step 3. I want to subtract n from both sides. Okay, well, if we go back up to the top up here, we said that n was 0 and 3 repeating. So what I really mean is I'm going to subtract n from step 1. Okay, so I'm going to come over here and I'm going to subtract n. So literally what I have written up in blue under step 1, I'm subtracting that. Now, When there is no coefficient in front of n, that's a 1. So when there's nothing there, we say that's a 1. So I just simply subtract this. So 10 minus 1 gives me 9n. And over here, I'm doing 3 and 3 repeating minus 0 and 3 repeating. So what that's going to give me is just the 3 left. Okay, and then our last step, step 4, is to solve for n. And reduce the fraction. Okay, so what that means is, like, to get n by itself, I need to divide by 9 on both sides of this equation. So I get n equals 3 over 9. But now I need to reduce. So I need to ask myself, is there something that can go into both 3 and 9? And the answer to that is 3. So this would become 1/3. So 0 and 3 repeating is the same as 1/3. Let's look at what happens if I have 2 digits. So now we're going to look at 2 repeating digits. So same thing, I want to still follow my steps. So step 1, we want to let n equal whatever number we have here. Actually, let me put this way. Let n equal the decimal. So it's going to look like n equals 0 and 24 repeating. This time, I want to multiply both sides by 100. So there's our main difference right there. So that means now n equals 0 and 24 repeating times 100. So when it was 1 digit, we multiplied by 10. When it's 2 digits, I'm going to multiply by 100. And the reason being is because now I need to move this decimal place 2 places. So I'm going to get 100n equals 24 and 24 repeating. All the other steps are the same. So step 3, subtract both sides by n. Okay, so I'm going to come over here, subtract that 1n equals 0 and 24 repeating. Okay, so that gets rid of the repeating decimal. So now I have 99 n equals 24. Okay, and then step 4, solve for n. And reduce the fraction. Okay, so I'm going to come over here, I'm going to divide both sides by 99. So I get 24 over 99. I need to reduce that. So what can go into both 24 and 99? Well, hopefully you can recognize that 3 does. So this is 8 over 33. So that means 0 and 24 repeating is the same thing as 8 over 33. You can always check to make sure you did it right by dividing 8 divided by 33 and make sure you get a repeating 24. Okay, after understanding everything we just learned, what would happen if we multiplied, what would happen if we had 3 repeating digits? So what would I need to multiply both sides of the equation by if we had 3 repeating digits? Maybe take a minute, pause the video, and write your answer. Hopefully, you said that the answer would be 1,000. So you need to be multiplying the number with the same amount of zeros as you have with the same amount of repeating digits. Okay, so the previous one, it was 2 repeating digits, so I multiplied by 100, where I had 2 zeros. All right, it's your turn to practice. I have 3 questions here. Change 0 and 6 repeating to a fraction. Change 0 and 18 repeating to a fraction. And then answer my last question. Could 0, 1, 2, 1, 2, 2, 1, 2, 2, continuing on that way, be changed to a fraction? Why or why not? Go ahead and pause the video and solve these problems. All right, hopefully at this time you've taken the time to pause the video and you worked these problems out. So let's see how you did. All right, so when I change 0 and 6 repeating to a decimal, you're going to see all the steps here. We have n is set equal to the 6 repeating. We multiply by that 10. We subtract that 1n, and then we find our fraction. So you should have gotten n equals 2 over 3. Okay, same thing here. We have n equals 18 repeating. We multiply by 100 because this has 2 digits. We subtract that 1n, and then we divide and get our fraction. So hopefully you had 2 over 11. Okay, and then our final one, could 0, 1, 2, 1, 2, 2, 1, 2, 2, 2, 1, 2, 2, 2, 2, 2 be changed to a fraction? The answer would be no. The reason being is because this is not actually a repeating decimal. It has a pattern, but I cannot put a line over the 1, 2, and that be the continuous problem. Okay, so this is actually an irrational number. Irrational numbers cannot be turned into fractions. Only rational numbers can. Okay, at this time you are ready to move on to your assignment.